Assalamualaikum warahmatullahi wabarakatuh. In this video, we're going to continue what we left off from the previous video. In the last video, we've discussed how to solve trigo equations by using the 5 steps that we call LARCA. Let's refresh our memory a bit. Those 5 steps are L, that is for linear form, and then A for basic angle, R for range, Q for quadrant, and then finally A for the answers. So, let's take a look at our last example here. We have 3 cos squared x plus 4 cos x minus 4 equals to 0, from 0 until 2 pi radian. This cos squared x can be written like this. So, if we rewrite this again, we're going to get 3 cos x squared plus 4 cos x minus 4 equals to 0. And to solve this, we are going to use LARCA, and the first step is L, which to make sure the trigo function in our equation has to be linear. And by linear, I mean that the highest power of that trigo function must be 1. But in our equation here, the highest power of this trigo function is 2. So, let's try to factorize this. To make this easier to see as a real quadratic, let's substitute this as something else. Say let u equals to cos x. Therefore, this equation will become 3u squared plus 4u minus 4 equals to 0. So factorize this, you are going to get 3u minus 2 and then u plus 2 and then equal to 0. And the value of u would be 2 over 3, and then from this one, u equals to negative 2. Remember, we are just using this u so we can easily factorize our quadratic trigo. So let's change them back. We are going to have cos x equals to 2 over 3 and cos x equals to minus 2. You see, instead of having a quadratic trigo equations that is very complicated to solve, now we have 2 linear trigo equations that is super easy to solve. So divide and conquer. Let's solve it one by one, starting with this. I'm going to put this to the side. Because we've done step number 1, to solve this equation, we just need to proceed to step number 2. For step number 2, we need to find its basic angle, so take out your calculator. As you can see here, our range is from 0 until 2 pi radian. That means this calculation should be in radian. And because of that, we need to make sure that our calculator is in radian mode. As you can see here, our calculator is in degree mode. So let's change this. Press mod 4 times and then press 2. Now we're going to find the basic angle. Just like what we did in the previous video, press shift, and since our function here is cos, press cos, bracket, and the value here is 2 over 3. Remember, do not put any sign when finding basic angle, which means if we have negative sign here, do not put that in your calculator. The sign that we have there is to indicate the quadrant that we are going to use in the 4th step. So our basic angle from this calculator here is 0.8411 radian. Moving on to the 3rd step, to find the range. In this step, we need to make sure that this theta, let's change this into x. This is a typo here. So our range is from 0 radian until 2 pi radian. In this step, we need to make sure that this angle match with our angle from the question. And since it's already matched, we don't have to change anything. So we are going to use this range as it is. Now we are going to proceed to the 4th step, which to find its quadrant. And to find its quadrant, we need to sketch its Cartesian plane with a stack. Since this angle here has positive value for cos, that means our angle should be in the 1st quadrant and the 4th quadrant. And the basic angle is 0.8411 radian. Lastly, we are going to find the answer here. As you can see from our range here, we know that this is a positive angle. And that means we are going to move in anti-clockwise direction. So let's put the range in our Cartesian plane. Starting from 0 here, it's going to move in anti-clockwise direction until 2 pi. Everything that this range touches will be our answer. So the range touched our angle in the 1st quadrant and the 4th quadrant here. The angle from the 1st quadrant is x equals to 0.8411 radian. and the second answer coming from this fourth quadrant here. So in radian, this one would be 2 pi minus 0.8411 radian. So these two angles are the solution for this first equation. We haven't found the solution for this second equation. So I'll put this to the side. For this second equation, we have cos x equals to negative 2. Before we start LARCA all over again, let me show you the graph for cos x. You see from this graph here, the highest value for cos x is 1. And the lowest value for cos x is negative 1. In another word, cos x is impossible to be more than 1 or less than minus 1. So when we have the value of cos x here equal to negative 2, the answer for this one is undefined, because it is impossible to have the value for cos x to be equal to negative 2. And therefore, our final solution for this question should be just from these two angles. So our solution is x equals to 0.8411 radian, 2 pi minus 0.8411 radian. So therefore, x equals to 0.8411 radian and 5.442 radian. With that, the end of this chapter. These are some exercises for you to try. I've said this again and again, and I'm going to say it once more. Make sure to try these questions to test your understanding, because if you don't try it yourself, you won't know what you don't understand from this topic. Then, if you have any confusion from this question, go ask your lecturers. They are more than happy to help you. So, thank you for your attention. Have a great day and take care.